A trailer-mounted solar cooker with a total mirror surface of 4 square meters was created in Sorède by a few members of the Friends of Father Himalaya Association. We named it Albera to recall the mountain of Sorède. We will first describe some past achievements that inspire us in the design of our Albera cooker. This cooker is not intended for commercial sale. In 1900, Father Himalaya created and installed a solar cooker in Sorède. It has a diameter of 5 meters. It was composed of 268 truncated cone-shaped copper alloy mirrors. The adjustment system was assumed, and meaning it had 2 axes of rotation, one vertical and one horizontal. The height of the focus depended on the altitude of the sun. The lower the sun, the higher the focus. This wasn't very practical for conducting experiments. In 1901, Father Himalaya created and installed a new furnace in Lisbon, Portugal. It was a parabolic concentrator with a surface area of 80 square meters, copper alloy mirrors. It also had an azimuth adjustment. The focus of constant height was mounted on a circular rail and had to be oriented facing the mirrors. In 1980s, Fraser Symington, a Canadian, developed several phased solar concentrators. In this series, the Helios model adopted the principle devised by Father Himalaya, but with several improvements. The height of the focus was constant. There were several adjustable rows of mirrors. In 2025, the Friends of Father Himalaya Association built the Albera concentrator. It had 48 mirrors distributed in 4 rows of 12 mirrors. The total surface area of the mirrors is 4 square meters. The concentrator is mounted on a trailer. This allows solar cooking in multiple locations. The mirror support frame is folded for transport to reduce wind resistance. This drawing shows the globe with the position of Sorède. Sorède's latitude is 42.5 degrees north. At this latitude, the maximum altitude of the Sun is 71 degrees on 21st of June. A minimum altitude of 15 degrees for the morning and evening has been set. The minimum and maximum position of the mirror are shown in blue. Each row of mirror rotates through the same angle depending on the sun altitude. The position of each row was chosen to ensure a minimum frame height, without obstructing the different optical paths from one row to the next, ranging from 15 to 71 degrees. A deflecting mirror reflects the concentrated radiation upward under the kitchen utensils. The position of each mirror in the rows was chosen so that the all optical paths are not obstructed while remaining within the road clearance. This short video shows the variation in the mirror angle depending on the sun's altitude. The mirrors are rectangular and measure 0.55 meters by 0.15 meters. The curvature is adjusted using 2 screws. This principle was patented by Felix Tron in 1955. There are 48 mirrors in total. The choice of materials and thickness of a mirror is important. To ensure good focus, the minimum radius of curvature of a mirror is 5.6 meters. This is the closest to the focal point. The stresses in the support due to this curvature must not be close to the breaking point. The reflection rate on mass must also be taken into account. The table shows a comparison between glass, PMMA plastic, and 316L stainless steel. We can see that the stress in the glass is close to its breaking point. We can also see that the stainless steel is heavy and has a poor reflection rate. PMMA seems to be the best choice. However, to ensure good horizontal flatness, a flat iron was added to each end of the mirrors. This concentrator allows 3 cooking modes: direct heating on a dark color container such as a casserole dish, saucepan or frying pan, a griddle, or an oven with light rays falling from below on a black aluminum plate. A Pyrex glass pane covers the bottom of the oven. During cooking, the setting must be changed regularly by rotating the trailer and adjusting the angle of the mirror. This concentrator can be transported on a trailer. Changing the operating position to the transport position or vice versa can be done simply by pivoting it around an axis. This concentrator is sturdy enough to travel. It will then be covered with a tarpaulin.